So looking at this problem, it's a circular helix. This is very clearly a cylindrical coordinate problem. It even has r, theta, and z in the picture, and it asks you to find fr, f theta, and fz. So the free body diagram, since the boy is a particle, I'm not going to draw the boy. I'm going to just draw a dot. And so there's going to be a r force, a counterclockwise theta force, and a z force, and that's just going to equal, very simply, m times the acceleration in the r, m times the acceleration in the z, and m times the acceleration in the transverse direction, or the theta direction. And so it's going to boil down to, if you can remember what in polar coordinates the radial, theta, and z accelerations are. And so if you remember AR, then in the radial direction you have r double dot, just the linear acceleration going out, and you have the centripetal acceleration coming back in, and a theta, okay, that's in the theta direction you had r theta double dot, which was just the angular acceleration times the radius, plus you had that weird Coriolis r dot, theta dot, and two of them. And we didn't talk much about the z because it's exactly the same as rectilinear. It's just z double dot. So all we're going to have to do is calculate these things. We're going to need to know r dot, r double dot, theta dot, and theta double dot. And to give you the equations, and so it should be easy to do. So let's write them all out. So r is given as 1.5 meters constant, which means r dot equals 0, and r double dot equals 0. They also tell you that theta is 0.7t, which means theta dot is 0.7, and theta double dot is 0. And finally, they give you z, the boy is dropping down, obviously, is minus 0.5t. Z dot is minus 0.5, and z double dot is 0. Okay, so given that, let's just figure out the accelerations. AR is r double dot, which is 0, minus r, which is 1.5, times theta dot squared, 0.7 squared, and this will all be in meters per second squared. A theta is r times theta double dot, which is 0, plus 2 r dot theta dot, so 2 times 0 times 0, which is 0 meters per second squared, and a z is z double dot, which is 0. So a whole bunch of these forces are going to be 0. So we get fz is maz, which is 0. F theta is ma theta, which is 0. And fr equals mar, which is, the mass was 40 kilograms, and the acceleration was minus 1.5 times 0.7 squared. And so that all equals minus 29.4 newtons. There you go. Let me double check to make sure that's right. So I just checked, and these are all correct.